welcome to the deep dive. Today we're tackling something pretty mind-bending.
Definitely out there.
It's an argument that takes physics, cosmology, the very nature of time, and uses it to make this, well, profound claim about your personal future.
Right, we're diving into a purely secular case for something like reincarnation.
Exactly. No faith, no spirits, no immaterial souls involved here.
No, this is all grounded in, well, pretty high-stakes stuff. Cosmology, probability theory, and really getting into the weeds of what personal identity even means.
That's the core of it. Our mission today is to really unpack this claim that sounds, frankly, a bit absurd when you first hear it.
It does have that initial shock value.
The claim being, the fact that you exist right here, right now, is basically conclusive proof that whatever makes you you is repeatable.
And therefore?
And therefore you'll be reincarnated infinitely many times.
It forces you to think about your own existence almost like a variable in a mathematical equation.
Okay, let's set it up. It starts with a couple of really big assumptions. If you combine them, you apparently get an impossible result.
That's the logical structure. Assumption 1. The universe's history is infinite. It stretches back forever.
Okay, infinite past. Got it.
Assumption 2. You, your specific consciousness, your identity, can only happen once. A one-shot deal. This is what philosophers call a restrictive theory of identity.
Right, like you're unique and unrepeatable.
Exactly. Now combine those.
Okay, let's unpack this.
Right.
So if we say time goes back forever, an infinite number of centuries, let's say, and my specific life, your specific life, is this totally unique event that can never happen again.
Right.
Then the chances of this unique event happening right now in this specific century out of an infinite number, that probability should be 0.
Absolutely 0. Think about it. If something can only happen once across an infinite timeline and each moment or century had an equal chance before it happened.
It must have already happened.
With mathematical certainty, it would have occurred infinitely far back in the past. The prediction, if you hold both infinite time and restrictive identity, is that you shouldn't be here now.
But here we are.
Exactly. You, the listener, are listening now. We're talking now. Our existence is certain. P no one knows.
So that prediction, the P-1 prediction, is just wrong, flat out contradicted by reality.
Which means at least one of the starting assumptions has to be wrong.
And the argument we're exploring today says the one we have to throw out is the restrictive view. The idea that you can only live once.
Precisely. Your current existence becomes the proof that the conditions making you are repeatable. It forces what's called a permissive view of identity.
Wow. Okay. So it's all driven by the sheer scale of infinity.
The logic of infinite time, yes.
Okay, but this whole thing hinges really heavily on that first assumption. Infinite time.
It's the bedrock, yes.
An infinite future. Yeah, most physicists seem okay with that. Universe is expanding forever, or maybe heat, death, whatever. But an infinite past, that feels like the real battleground, philosophically and scientifically.
It is, and it's interesting because there's a strong metaphysical intuition pushing for it. Think about space.
Okay.
Can you imagine an edge to space?
Yeah.
Like a wall beyond which there's nothing, no more space.
No, my brain immediately asks, well, what's beyond the wall? It feels impossible.
Right. Our intuition resists a boundary to space itself. The argument is that the same intuition applies to time. Can you really conceive of a moment before which time itself didn't exist?
I see the parallel. If you say time began, you instinctively ask, what happened before the beginning?
Exactly. The very concept of beginning seems to require a before. For time to come into existence, there must have been a time when it wasn't, followed by a time when it was.
Which is a contradiction in terms. You need time to have a transition from no time to time.
Any event, any transition, any coming into being takes time. It happens over time. So the idea of time itself starting seems, well, metaphysically awkward, to put it mildly.
Even if you bring in, say, a creator, like God, creating time.
The act of creation is still an event. An event happens at or during a time. So it seems to presuppose the very thing it's supposed to be creating. It's a classic philosophical puzzle.
Okay, so that's the intuitive push for an infinite past. But intuition can be wrong.
What about the logical arguments against it? The idea that you can't complete an infinite series.
The actual infinity problem. Yes. The argument goes, if the past is infinite, then an infinite number of events, say years or seconds, must have already passed to get to now. But you can't finish counting to infinity. So how could we possibly have reached the present?
Right, it sounds like a paradox.
It does, but we can actually see why it's not a deal breaker by flipping Zeno's paradoxes around.
Zeno, the runner who can never reach the finish line because he has to cover half the distance and half the remainder infinitely. That's the one. But we know runners do finish races, right?
Yeah, obviously.
So that shows that an infinite series of physical steps can be completed in a finite amount of time. The runner crosses the halfway point, the three-quarter point, the 7/8 point, all infinitely many points, and yet reaches the finish line.
Okay, so how does that help with the infinite past?
Yeah.
That seems like going forward in time.
The key insight comes when you trace the runner's motion backward from the finish line.
Okay.
Just before they crossed the line, where were they?
Halfway through the last tiny segment.
Right. And before that. Halfway through the segment before that, you can trace it back infinitely. Half the total distance, 3/4, 7/8, 15/16. It's an infinite sequence of positions the runner must have occupied.
And crucially, that sequence going backward. It doesn't have a first step, does it? There's no first fraction of the distance when you work backward from the end.
Precisely. It's an infinite series without a beginning point that is demonstrably completed the moment the runner crosses the finish line.
So the physical possibility of completing an infinite series without a first member means the argument you can't have completed an infinite past doesn't hold water.
Exactly. Philosophically, the infinite past is perfectly possible. The logical objection based on completing infinity is flawed.
Okay, philosophically possible. But then there's the science. The Big Bang. Standard model says, what, 13.8 billion years old? Finite past. End of story.
Well, not quite end of story. The standard Big Bang model certainly suggests a finite past, but it comes with its own huge unresolved problem.
Which is?
Not just that it started, but how it started. The conditions required at the very beginning of the Big Bang are astronomically improbable.
You mean the low entropy state, the universe starting incredibly ordered.
Incredibly ordered. Entropy is basically disorder, and the second law of thermodynamics says things tend to get more disordered over time. So finding the universe starting in this pristine, hyper-ordered state is bizarre.
How bizarre? Is there a number?
Oh, yes. Roger Penrose put a number on it. The odds of the universe randomly starting with that low level of entropy are less than 1 in 10 to the power of 10 to the power of 124.
Okay, that number's meaningless. It's too big.
It's staggeringly huge. Picture every single particle in the observable universe. Turn each one into a zero. You still wouldn't have nearly enough zeros to write down the denominator of that fraction.
So it's basically zero probability for it to happen by chance, an inexplicable degree of fine-tuning right at the start.
Exactly. And that improbability is the problem, because if you allow the universe to just pop into existence in an unexplained, super improbable low entropy state,
Then why that state? Why not some other improbable state?
precisely. Which leads to this really uncomfortable thought experiment, the 1950 start hypothesis.
Uh-oh. I feel like this is going somewhere weird.
It is. Think about the universe in 1950. Was its entropy higher or lower than the Big Bang singularity?
Higher, surely. Much more disordered by then.
Right. More disordered means higher entropy. And a higher entropy state corresponds to many, many more possible physical arrangements of particles than a low entropy state.
Okay,
So if we're just allowing unexplained starting points, a universe instantaneously popping into existence in the state it was in 1950, complete with, people having false memories of World War II, dinosaur fossils already in the ground perfectly arranged, that state, while still improbable, is actually vastly more probable mathematically than the initial Big Bang state.
Whoa. Wait, so it's statistically more likely for the universe to have just started in 1950 with fake history than for the Big Bang to have started the way it did?
If we simply accept an unexplained low entropy beginning as possible, then yes, the 1950 start has higher entropy, covers more phase space volume. It's technically less of a statistical fluke than the Big Bang start.
But the 1950 idea is absurd. We reject it because it posits this arbitrary beginning with built-in fake history for no reason.
Exactly. So the argument goes, if the 1950 hypothesis is unreasonable for that reason, shouldn't we also find the Big Bang's unexplained ultra-low entropy start equally unreasonable? It forces us to ask, what caused or selected that incredibly specific starting condition?
Which pushes us back towards models that don't have that unexplained beginning.
Right, models that try to resolve this low entropy problem. And many of those inherently involve an infinite past. You have cyclical models.
Like Steinhart-Turok or Penrose's CCC model, where the universe bounces or cycles infinitely.
Yes, infinite big bangs and big crunches, or cycles of expansion and decay. These potentially reset entropy or dilute it, avoiding a singular, inexplicable start.
Or maybe multiverse ideas? Our Big Bang is just one event in a much larger, eternally existing multiverse.
That's another possibility. An infinite multiverse could be eternally old, periodically spawning new bubble universes like ours with their own finite apparent ages.
So the takeaway here isn't that the Big Bang is wrong, necessarily, but that the finite past interpretation faces this massive low entropy problem.
A problem so significant that models with an infinite past remain very much on the table, scientifically and philosophically.
And if the past is infinite, or effectively infinite in a multiverse,
Then the rest of the argument we're discussing today becomes unavoidable.
okay, so let's assume we accept the infinite past, at least provisionally, because of these problems with a finite start. What happens next?
Well, an infinite past seems to force us into the realm of eternal recurrence.
The Nietzsche idea. Everything happens again and again, exactly the same way.
That's the popular version, yeah. Though the idea goes back further, even to Seneca, the core concept is, given infinite time and assuming a finite amount of stuff or possibilities, every possible arrangement must eventually repeat.
You need that finite constraint, though, right? The sources mentioned, it's not absolutely guaranteed a priori. Like, you can imagine two particles just flying away from each other forever, never repeating their configuration.
That's true. You need some kind of boundary condition, and that's where the physics comes in, specifically the Poincaré recurrence theorem.
Okay, Poincaré recurrence. What does that say?
Basically, it states that any physical system that is confined to a bounded region of phase space.
Whoa, okay, bounded region of phase space. Let's translate that.
Right. Phase space is just a way mathematicians map out every possible state of a system, like the position and momentum of every single particle.
Okay.
Bounded means the system has limits. Finite total energy, finite number of particles contained within a finite volume of space. It can't just expand or change forever into totally new territory.
So, like our shuffling deck of cards analogy from earlier.
Yeah.
52 cards, finite number of arrangements, $52. If you shuffle forever.
You are absolutely guaranteed, with probability 1, to eventually return arbitrarily close to the original starting order. Not just once, but infinitely many times.
Because the system is bounded, it can't escape into some state outside the $52 possibilities.
Exactly. The Poincaré recurrence theorem says the same applies to any bounded physical system. If the universe itself is bounded, maybe like in those cyclical models,
Then the entire universe, or at least regions of it, must eventually repeat its state, or come incredibly close to repeating it.
infinitely, often, given infinite time.
Okay, but does the whole universe need to repeat for this argument about reincarnation to work?
Ah, good question. No, it doesn't. That's a crucial clarification. The argument only requires the recurrence of a complex physical state that is sufficient to constitute you.
A sort of local recurrence, a Poincaré clone, as the sources call it.
Precisely. Just the specific arrangement of matter and energy, the brain state, the information patterns that make up your consciousness and identity, that configuration, according to the theorem, must eventually reappear somewhere, sometime, in an infinite timeline within a bounded system, or even potentially in an infinite unbounded one through sheer chance, though that's a different path.
And this is where the identity crisis really hits. So, trillions upon trillions of years from now, maybe in a different cosmic cycle or a distant part of the multiverse, a being spontaneously assembles, or is born, that is physically identical to me. Same atoms in the same arrangement, same brain wiring, same memories, same personality quirks.
Down to the quantum state, let's say. Indistinguishable.
Is that person me?
Yeah.
Am I reincarnated? Or is it just a perfect copy?
And that hinges entirely on your underlying theory of personal identity.
Right. The two camps. Restrictive versus permissive.
Restrictive theories are the ones that usually demand continuity. Spatiotemporal continuity, you have to trace an unbroken path through space and time, or maybe a unique causal chain.
Like, my consciousness now has to be causally linked moment to moment, back to my consciousness a second ago. If there's a complete break death, and then a new being appears later, even if identical.
The restrictive view says, nope, that's a different token individual. It's a copy, not the original. Like your broken mug example, the new identical mug isn't the same mug.
That feels like the default intuitive view for many people.
It often is, but then you have the permissive theories.
What do they say?
They argue that what makes you you isn't necessarily an unbroken causal chain, but the instantiation of certain properties or conditions.
Like what?
It could be a specific complex brain configuration, or maybe a set of deeply ingrained character traits and memories, or certain dispositional properties, how you'd react in certain situations. If those specific, complex, identity-conferring conditions are met again.
Even if there's a huge gap in time, like billions of years.
Yes. The permissive view says the person resulting from the reinstantiation of those conditions is you. It's a continuation of your existence, just with a temporal gap.
Okay, that's a much weirder idea of identity for sure.
It is less intuitive for many.
Yeah.
But here's the clever part of the overall argument we're exploring.
It doesn't just ask us to prefer the permissive view.
No. It uses the zero probability proof we discussed earlier to argue that the restrictive view, when combined with an infinite past, leads to a contradiction with reality.
Meaning the restrictive view must be false.
Which, by elimination, leaves the permissive view as the only viable option if the past is infinite. Your existence now becomes the proof that identity must be permissive and repeatable.
Okay, let's get into that engine room then, section 3. This is the core logic, the zero probability proof that supposedly forces us to accept this repeatable permissive identity.
Right. This is where the probability maths meets the philosophy of identity head-on.
First tool we need. How do we even define evidence here?
We use the standard Bayesian idea of evidence. Something counts as evidence, E, for a hypothesis, H, if that evidence is more likely to happen if the hypothesis is true than if the hypothesis is false. So if PEH is greater than PE-text.
Basically, the evidence makes the hypothesis more probable than its alternatives. The hypothesis that best explains the evidence, or at least doesn't predict the evidence is impossible, wins out.
Exactly. The hypothesis that assigns a non-zero probability to what we actually observe survives.
Okay, but then there's this crucial point about indexicality. What exactly is our evidence? It's not just general knowledge.
This is absolutely vital. Let's go back to that coin flip example again, nice and slow.
Okay, 10 heads in a row.
If you state the evidence non-indexically, like somewhere, sometime, a coin landed heads 10 times in a row. Well, okay. In a huge universe with potentially infinite time and space, that's not that surprising. It weakly supports the idea the universe is big and full of random events.
Yeah, that feels weak. My observation feels much stronger.
Because your actual evidence is indexical. It uses terms like I, this, now. Your evidence is this specific coin, the one I'm looking at right now, just landed heads 10 times consecutively.
Right. The fact that millions of other coins might be getting flipped elsewhere doesn't make this specific result any more likely here and now.
Precisely. The indexical here and now and this specific instance is the key. So applying that to our existence.
Our evidence isn't the abstract, non-indexical fact. Consciousness exists somewhere in the universe.
No, that's trivially true and doesn't help us.
Our evidence, the specific, concrete, indexical fact, let's call it L, is I'm alive now. My consciousness is observing the universe at this present moment.
That's the evidence, L. And we need to test the competing theories of identity against the probability of L.
Okay, so now, the zero probability proof itself. You laid out 3 conditions that lead to absurdity. Let's recap them.
Condition 1, restrictive identity. Your specific life, this conscious experience E, can occur at most once in all of history. It's unrepeatable.
Got it. 1 life per customer.
Condition 2, infinite history. The past duration of the universe is infinite.
Also got it. We argued for its plausibility earlier.
Condition 3, temporal indifference. This one's a bit subtle. It states that a priori, before we know we exist now, the eventee, your life starting, was no more likely to occur in this present time interval, say this century, than it was in any other equivalent time interval in the infinite past.
Why do we need to assume that? Couldn't there be something special about now, cosmologically speaking?
Well, if we just declared that now is intrinsically special and vastly more likely to produce you than any past century, we'd be cooking the books. We'd be introducing an unexplained bias towards the present moment just to save the theory.
Right, that feels like cheating.
Yeah.
To be fair, we have to assume any century is as good as any other, before the fact.
Exactly. It's a principle of insufficient reason applied to time. Unless we have a specific physical reason to believe otherwise, we treat all time intervals as equally probable locations for a one-off event.
Okay, so conditions are 1 life only, infinite past time, no specialness about now. What happens when you combine them?
Let's divide that infinite past into equal intervals, say centuries. Now, consider the probability that E, your unique life starting, occurs in the present century, given it hasn't happened before.
Okay.
Under the restrictive view, let's say we assign some tiny non-zero probability to it happening now. Call it P. Maybe P is 1 in a trillion. Doesn't matter how small, as long as it's not 0. Because of condition 3, temporal indifference, the probability of E having occurred in the previous century, given it hadn't happened before that, must also have been P.
And the century before that.
Also P and the one before that. Also P, stretching back infinitely many centuries into the past.
Uh-oh, I see where this is going. Since E can only happen once, condition 1, these probabilities across different centuries are mutually exclusive potential occurrences of the single event E.
Correct. And the total probability of E having happened at some point before now is the sum of the probabilities for each past century.
But you're summing an infinite number of identical non-zero probabilities, P plus, P plus, P plus, infinitely.
What does an infinite sum of tiny positive numbers give you?
Infinity. Or, in probability terms, it means the total probability calculation blows up, goes way past 100%. If P was 1%, after just 100 past centuries, the populated probability of it having already happened reaches 100%. Over an infinite past, it's infinitely certain it should have already happened.
That's the mathematical breakdown. The only way to keep the total probability from exceeding 1 or 100% over an infinite past, given that the event can only happen once, is if the probability assigned to it happening in any specific interval, like P, is
Exactly 0.
exactly 0. So the combination of restrictive identity, 1, and infinite past, 2, under the fairness condition of temporal indifference, 3, logically predicts that the probability of you being alive now must be precisely 0.
It predicts you shouldn't exist.
With mathematical certainty.
But I do exist.
Yeah.
PL is undeniably 1.
Which means the conjunction of those 3 premises leads to a direct contradiction with observed reality. Something has to give.
And since we argued the infinite past 2 is plausible, and temporal indifference 3 seems like a necessary fairness condition for the calculation.
The premise that must be rejected is the first one, restrictive identity, the idea that you can only live once.
So the only way for the probability of my existence now to be non-zero in the face of an infinite past is if the conditions that constitute me are not a one-off event. They must be repeatable.
That's the conclusion. The permissive theory of identity is forced upon us by the sheer fact of our existence in what appears to be an infinitely old reality.
And it doesn't matter how intuitively strange permissive identity feels or how incredibly rare the reinstantiation of me might be.
Doesn't matter. If the restrictive theory predicts PLL dollars and the permissive theory predicts PLL do, no matter how small that positive number is, then our observation that we exist now provides effectively infinite evidence in favor of the permissive theory over the restrictive one. 0 probability is a death blow for a scientific or philosophical theory trying to explain reality.
Okay, let's try and make this even more concrete with that demon analogy the sources used. It helps distinguish between very unlikely $2 all and impossible to $2.
Good idea. It clarifies the logic.
So imagine you're kidnapped. You don't know who by. There are 2 possibilities. Demon Q1.
Demon Q1 sets you a finite challenge. He'll flip a fair coin 10 times. You live if and only if it comes up heads every single time.
Okay, the odds aren't great. That's
Yeah.
1 divided by 2 to the power of 10. Oh,
1 in 1024. Low probability, but crucially, it's not 0. P-Tech survive Q1 dollars.
right. Then there's Demon Q2.
Demon Q2 sets you an infinite challenge.
Mhm.
He'll flip a fair coin an infinite number of times in the next hour. You survive if and only if every single flip comes up heads.
An infinite sequence of heads, the probability of that is.
Exactly 0. P-Tech survive Q2. It's mathematically impossible.
Okay, so those are the 2 possibilities. Now, the experiment happens. You wake up later unharmed. You survive.
You are alive. That's your evidence, E.
The question is, which demon must have captured you?
The inference is absolute, isn't it? It must have been Demon Q1.
Because Q1 allowed for a non-zero chance of survival, however small. Q2 predicted your survival was impossible. Since you did survive, Q2 is ruled out completely.
Precisely. Your survival E is conclusive proof you face the challenge where PE will.
Now, translate that back to our identity argument.
Demon Q2 is like the restrictive identity theory operating within an infinite past. It predicts PRO 0. Impossible.
Demon Q1 is like the permissive identity theory. It might say the probability of the conditions for you recurring right now is incredibly tiny, maybe like winning the cosmic lottery, but it's not 0. PTs exist now.
And your observation, the undeniable fact that you are alive now,
Is the survival evidence. It conclusively refutes the P-disorder theory restrictive and confirms the only remaining possibility, the P-disorder theory, permissive.
Therefore, your existence becomes the proof that the conditions that constitute you must be repeatable.
And if those conditions are repeatable, and we live in a universe governed by something like Poincare recurrence operating over infinite time,
then you will repeat. Not just maybe, but with certainty, infinitely many times. Reincarnation, or at least recurrence of self, becomes a logical consequence of existing now in an infinite past.
Okay, that is a very powerful, very counterintuitive line of reasoning. But it feels like it runs straight into some major roadblocks, right? We need to tackle the objections.
Absolutely. Any argument this radical is going to face serious challenges.
The big one from physics seems to be the second law of thermodynamics, the heat death of the universe.
Right. The standard picture. Entropy always increases. The universe coasts towards a state of maximum disorder, uniform temperature, everything evenly spread out. Cold, dead, forever.
And in that state, no complex structures can form. No stars, no planets, certainly no brains, no life. So even if time is infinite, the interesting part of time is finite. No future recurrence possible. Game over for reincarnation.
It definitely sounds like a fatal blow. If the universe inevitably ends up in a state hostile to life, how can you ever recur?
But the rebuttal focuses on what the second law actually is, doesn't it?
Exactly. The second law isn't an absolute commandment saying entropy must always and forever increase in every single spot. It's a probabilistic tendency for isolated systems overall.
And crucially, the Poincare recurrence theorem, which we relied on earlier,
Directly contradicts the idea that a bounded system, once it reaches maximum entropy, stays there forever. The theorem guarantees that if the system is bounded, it must eventually, given enough time, fluctuate back towards lower entropy states, including states arbitrarily close to its starting point.
So even in a universe that seems to have reached heat death, random fluctuations are still happening.
Yes. Think of it like, imagine a gas spread perfectly evenly in a box. That's maximum entropy. But the individual gas molecules are still whizzing around randomly. Just by pure chance, is it possible that for a brief moment, significantly more molecules might cluster in one corner?
Yeah, incredibly unlikely for a large number, but possible.
That's a spontaneous entropy decrease. Now scale that up. In the supposedly dead maximum entropy future universe, random quantum fluctuations, thermal fluctuations are still occurring.
And over infinite time. Even ludicrously improbable fluctuations become possible, like enough particles randomly arranging themselves into a functioning brain, the Boltzmann brain idea.
That's the concept, yes. While a Boltzmann brain appearing is mind-bendingly improbable, the probability isn't strictly zero. And if that can happen, then a fluctuation large enough and complex enough to recreate the exact physical state corresponding to a Poincare clone of you is also not strictly zero probability.
So even if the odds are 1 in a Googleplex cubed over infinite time,
improbable becomes certain to happen eventually, just extremely rarely. Infinite time makes even the tiniest non-zero probability happen, and happen infinitely often.
Okay, so that's the random fluctuation route to recurrence after heat death. But what about the cyclical models?
They potentially offer a much more efficient route. If the universe undergoes cycles, like the Big Bounce or Penrose's CCC model, there might be mechanisms at the boundary of each cycle, the crunch, the bounce, the conformal rescaling, that systematically reset or dilute entropy.
So you don't have to wait for a 1 in a zillion random fluctuation. The universe itself might have a built-in reboot mechanism.
Exactly. Either way, whether through random fluctuation in a heat death scenario or through cosmic cycles, the Poincare recurrence logic suggests that states will repeat. The heat death isn't an absolute barrier in infinite time.
Okay, objection 1 deflected. What about the second big one? Physicalism and identity. The Mona Lisa problem.
Right. The objection goes, if we're just physical beings, complex arrangements of matter, physicalism, then we're like paintings. If the Mona Lisa's burned, and years later someone creates a perfect atom-for-atom copy, it's still just a copy. It's not the original Mona Lisa.
So the argument is, if physicalism is true, these future Poincare clones aren't you, they're just replicas. True reincarnation requires something non-physical, like an enduring soul dualism, to carry identity across the gap.
It's a common intuition, but the counter-argument is that physicalism is actually compatible with the permissive identity forced by the probability argument. We just need a slightly different way of thinking about what a physical person is.
And that's where the temporally gappy space-time worms come in. That phrase definitely sticks.
It's memorable, isn't it? The idea is, maybe we shouldn't think of a person like a solid object that needs continuous existence like the Mona Lisa. Maybe a person is more like a persistent pattern or structure that exists across time.
A pattern that can have...
Gaps, temporal gaps. Think about spatial gaps first. You use the chair analogy. Your favorite chair gets taken apart, the legs go to one place, the seat to another, stored for years. When it's reassembled, is it the same chair?
Yeah, I'd say so. It's made of the same parts, reassembled into the same structure. We don't usually think it needs a chair soul to bridge the spatial gap.
Exactly. We accept identity across spatial gaps based on composition and structure. The argument is, why not accept identity across temporal gaps on the same basis?
So the space-time worm is the total entity existing across time. And if that pattern, that structure, gets reinstantiated after a break, it's still the same worm, just with a gap in its timeline.
That's the proposal. The identity lies in the complex structure and the internal causal relationships that define that structure being repeated, not necessarily in unbroken continuity. If the zero probability proof forces us to accept that identity is repeatable, permissive, then a physicalist just has to adopt this kind of gappy existence view. It's compatible.
Okay, so physicalism might survive, but what if someone is a dualist? What if they believe in souls? Doesn't that kill the argument? The Cartesian dualist objection?
You mean if identity is tied to a unique, immaterial, non-repeatable soul, then surely recurrence of the physical body doesn't mean recurrence of the person because the soul is missing or different.
Yeah. Seems like dualism provides an easy out.
Surprisingly, their argument claims the same logical pressure applies even if you assume dualism.
How?
It depends on why your specific soul is connected to your specific body now. If you adopt what the sources call a restrictive dualism, meaning the specific causal conditions required for your unique soul to become embodied are themselves a one-off, unrepeatable event in cosmic history.
And we're back to square one.
Exactly. Then the event E isn't just your body forms, it's your unique soul gets embodied. If that combination can only happen once, restrictive dualism, and the past is infinite,
then the probability of it happening now is zero.
Correct. The zero probability proof applies just as well. The fact that you are experiencing consciousness now, presumably your soul embodied, becomes evidence against restrictive dualism.
So even the dualist is forced to conclude. What?
They're forced into a permissive dualism. They have to conclude that the causal conditions required for their specific soul to find and inhabit a suitable body must be repeatable. Maybe certain physical configurations attract certain souls, or maybe the conditions are set by something else, but whatever they are, they can't be unique if the past is infinite.
Wow. So whether you're a physicalist or a dualist, the argument claims your existence now in an infinite past forces you to accept that the conditions for you, either your physical pattern or your soul's embodiment, are repeatable.
That's the thrust of it. The core logic doesn't depend on the physicalism-dualism debate itself.
Okay, one last major objection. The paradox of universal surprisingness.
Ah, yes, this one feels tricky.
The argument goes, look, if the past is infinite, then under the restrictive view, the probability of being born now is zero. But the probability of being born last century would also have been zero. And the century before that, zero. And so on.
Right. Any specific time would have been preceded by an infinite past.
So any time you happen to be born would be equally surprising, meaning it would have had zero probability according to the restrictive theory. If every outcome is predicted to be impossible, then observing one of those impossible outcomes doesn't actually tell you anything specific. It's like universal surprise cancels itself out. Nothing is learned from existing now.
It sounds plausible, but it misunderstands what the zero probability proof is actually comparing.
How so?
We're not comparing P versus you live now text restricted. Both of those might indeed be zero under that flawed theory. That's not the comparison that provides evidence.
What is the comparison then?
We are comparing the predictions of the theories themselves about the evidence we do have. L, you live now. Specifically, we compare PEL, text permissive theory, versus PEL, text restrictive theory.
Okay.
We know PEL, text permissive theory, is greater than zero. It might be tiny, but it's positive. The permissive theory allows for your existence now.
And we calculated that PL text restrictive theory plus text infinite past 1 is exactly 0. The restrictive theory predicts you cannot exist now.
So the evidence L, you exist now, makes the permissive theory infinitely more likely than the restrictive theory. The fact that the restrictive theory fails completely to predict the observed reality is the crucial point. It's not about how subjectively surprised we feel about when we exist. It's about one theory making a prediction of impossibility that is flatly contradicted by fact, while the other theory allows for the fact.
So the universal surprisingness is irrelevant because the key is that one theory assigns zero probability to the actual outcome and the other assigns non-zero. That's the refutation.
Precisely. It's a standard Bayesian refutation based on predictive failure. The restrictive theory predicts PL dollars, we observe a dollar, therefore the restrictive theory is falsified. So let's just quickly recap the whole chain of reasoning. It's essentially a four-step philosophical derivation leading from cosmology to, well, personal immortality of a sort.
Okay, step one was establishing the plausibility of the infinite past.
Right. We looked at the metaphysical intuition against a beginning of time, the flaws in the can't complete infinity argument using the Zeno reversal, and critically, the massive low entropy problem facing the standard finite Big Bang model, which keeps infinite past models like cyclical universes or multiverses in play.
Step two, if time is infinite and we have bounded conditions, like in cyclical models or even just relying on Poincare recurrence over vast timescales, we get eternal recurrence.
Yes, the guarantee that complex states, including those sufficient to constitute a Poincare clone of you, must repeat infinitely often.
Then step three, the absolute core of it. Using our present existence, I am alive now, as indexical evidence.
We showed that combining an infinite past with a restrictive view of identity, you only live once, leads to the prediction that the probability of you being alive now is zero.
Which is contradicted by the certainty of our own existence. So the restrictive view has to go.
Meaning the conditions that constitute you must be repeatable. Permissive identity is forced upon us. That was the zero probability proof, illustrated by the demon analogy.
And finally, step four. If the conditions for you are repeatable, permissive identity holds, and eternal recurrence guarantees repetition of states,
then you will be reincarnated, or at least recur infinitely many times. And this holds whether you lean towards physicalism as a gappy space-time worm, or dualism, requiring repeatable conditions for soul embodiment.
Okay, wow. It's a dense argument, and here's where it gets really interesting, for me anyway.
Darn.
The entire strength of this very logical, very physics-based argument seems to boil down to just how strongly we commit to those two initial premises, right?
Which two?
One, that the universe really does have an effectively infinite past, whether through cycles, a multiverse, or something else that avoids that inexplicable Big Bang start. And two, that principle of temporal indifference, that there's truly nothing special about this cosmic era that makes life like ours wildly more probable now than it could have been eons ago.
Yes, the argument definitely rests on those foundations. If the past is truly finite, or if there's some unknown physical law that dramatically privileges the present for the emergence of observers like us, then the zero probability calculation breaks down.
So this whole deep dive really forces you, the listener, to grapple with what you even means. Is identity tied to this single unbroken thread of consciousness in one lifetime? The restrictive view.
Which seems to lead to a probabilistic paradox if time is infinite.
Or is you something more fundamental? A complex pattern, a set of conditions that can be repeated, a potential for recurrence that's just inherent in the physics of an infinite reality.
It suggests that if the only way to make sense of your own presence now, mathematically, within an infinite history, is to accept that your identity is repeatable, then maybe that's what identity is. You become this discontinuous, potentially eternal entity defined by pattern, not by continuity.
So the final thought to leave everyone mulling over is this. If the universe stretches back infinitely, and here you are undeniably existing now, what's fundamentally more improbable?
What are the options?
Option A. Your existence is just a complete cosmic fluke, an event of probability zero that somehow happened anyway, violating the apparent logic of infinity. Or option B. The very concept of you isn't a one-off fluke at all, but is instead a repeatable set of physical or causal conditions, destined to recur again and again, as dictated by the consistency of physics operating over infinite time. Which pill is easier to swallow?
That really is the existential choice the argument puts before us.